Qing on nested virtualization.
Did I get it right?
Hello, good afternoon. I'm Qing from Intel Open Source Technology Center, and I think it's kind of late, so hopefully I won't take too long. I introduced nested virtualization on Zen, and which is also what I'm currently working on. This is the agenda. First, I'll have an overview about what and why we're doing on nested virtualization and the basic idea of it. And then we'll present you the architecture of the current work and the inner working of nested virtualization. The nested virtualization is kind of complicated, not confusing as it's internal, but it has a really simple basic idea. So hopefully I'll get you the big picture of it. At last, I'll talk about the status of my current work. So, what is a nested virtualization? This name is kind of self-descriptive. So, nested virtualization is, generally speaking, running virtual machines inside another virtual machine. And to be more precisely, it's running a VMM as a guest or in a guest, whatsoever. This idea itself is quite interesting since virtual machines like some kind of vision, and by going nested, you get vision into another vision. If you have ever watched the Matrix, it's like a matrix inside another matrix. This idea was quite naturally implemented in the older virtual VMM because at that time software technologies are used. We used software-based technology to realize the VMM, and at that time this is quite natural. But since the introduction of hardware technologies like the Intel VT or the VMX, things have changed because now the VMM happen to rely on some special hardware, where these kind of hardware have never been actually virtualized in the VMM. So the VMM presents an upper layer without these hardware, so the nested virtualization cannot be automatically done for current situation. So our work here is to run the nested virtualization specifically for the hardware-based virtual machines, i.e. run a VMX guest inside another VMX guest. So why are we doing this kind of job? First, as Ian pointed out this morning, the virtualization has been becoming ubiquitous, like in the cloud or the Zen client. If Zen is everywhere, what if you need another layer of virtualization? What if you want to run a virtual machine in a typical client? So at this situation, the nested virtualization is needed. And moreover, since this hardware technologies has been more and more popular, ordinary OS begins to use them. For example, the notable example is Windows 7. It has an XP compatibility mode, and this mode requires VMX. If we run a Windows 7 as a Zen guest, and there is no nested virtualization capability, these modes is not available. It also has some minor advantages. For example, very similar to that we use the VMM as a debugging and analysis facility for an ordinary OS. The nested virtualization capable VMM can be used as a facility to investigation on the normal VMM behavior. For example, you can know how a particular VMM works and get some statistics and performing its optimization. So the fundamental idea is really simple, as I just mentioned. The fundamental idea of nested virtualization is to virtualize the VMX. If we have this piece of hardware and the VMM uses this piece of hardware to function, we have to virtualize them in the guest, and then the guest can use it to act as a VMM. So the basic idea is to present a virtualized VMX to the guest, and this includes all kind of VMX. It has data structure. In this case, it's VMCS as a controlling structure, and some sort of instructions that is added by this extension, and its behavior, its execution flow. All things should be virtualized, and that is our goal for the nested virtualization. By talking about the virtualization of VMX, I think although many of you may already be familiar with VMX, we can still have a closer look on how it works. So we here has a brief VMX revisit. So VMX has several key concepts, including a control structure that controls the behavior of the guest, and have some execution flow transitions as the VM entry and VM exit. You can see the figure on the right. It demonstrates the typical behavior of VMX guest and the VMM. There is a controlling VMCS, control the guest behavior. It has a guest running context, and it behaves as an information exchanger between the VMM and the guest. Basically, the guest runs in the hardware context, but it cannot perform some privileged operations. When these kind of operations happen, there is a VM exit to the VMM, and the VMM can fix the situation by either performing for the guest or inject some exceptions at that time, and then going back to the guest by VM entry. The VM entry is achieved by an instruction that either is a VM resume or VM launch to go into the guest. You see these sort of VM entry and VM exits, these transitions, this series of transitions drive the whole execution forward. So let's come to the general architecture of the nested virtualization. Here on the figure is a common scenario of a normal VMM, or normal DAM, without the nested virtualization. This level 1 guest, this is HVM guest with VMS CS controller, and this is a common case. If we want to implement nested virtualization on top of that, we actually need to install another VMM into this level 1 guest and start another virtual machine as the level 2 guest. Here, I'd like to come to have some words about the terminology. Well, when I was doing this nested virtualization, I partly find one of the most confusing parts is the terminology. When you want to address some guests in a specific layer, you find that the terminology is, you often get yourself confused. So what I used here is the level notation. I put these layers into different level number. For example, the then as VMM itself is a level 0 VMM, and normal guest is a level 1 guest, and the nested guest is a level 2 guest. And it can also be referred to as the VMM and nested VMM and the nested guest. I may use them interchangeably in the following, where it just needs to find a notation or the terminology that can best express the situation and what their